This is mind-bending. We won't survive this. It's exactly what I've been trying to warn people about. I was not intending to remark on the supposed structures in the bedrock below Khafre's pyramid, but so many people have been asking me about it, I thought I would shed a little light on the matter by looking at it through the geological perspective. So I want you to join me here because there's some pretty amazing things that have played out over the Egyptian environment over the last, say, couple of million years. And we're going to talk about that, and I think some of it's pretty mind-blowing. As far as the whole question of the structures under the Khafre pyramid, I'll say I'm ambivalent. Certainly it would be exciting if that was real. I will certainly admit right off the bat that that would be very exciting if it was real. However, you know, tipping my hat to Carl Sagan, I've got to agree that extraordinary claims require extraordinary proofs. And so I would definitely be requiring some serious evidence over and above what I've seen so far. And with that in mind, I think what I'm going to do, though, is talk about what could be possible. And I think let's take the number of possibilities here. Let's assume that the synthetic aperture radar images are not doctored in any way. It does appear that some kind of a structure exists. But the ambiguity of the images precludes any conclusion as to whether these apparent images or structures are natural or man-made. I'm biased towards the natural, and we'll go through some material here, some of the geological studies of Egypt that would seem to suggest the possibility or probability that there would be cavities within the limestone bedrock of the Giza Plateau. So let's start out with some geological context to the question, and then we'll consider what this may suggest. Now, most of the bedrock comprising the Giza Plateau is Eocene limestone from the Eocene period of the geological times table. Now, there's some other, for the geologists, there's some mixed in dolomites, which are also calcium carbonate-based rocks. There's some sandstone, not much, but there is some sandstone and marls that are you might say thrown in for good measure, but to considerable depths, the mass of the limestone, the mass of the bedrock is limestone. Now, if you know anything about petrology, which is the study of rock composition, you know that carbonate-based limestone rocks are soluble in acidic water. And this is one reason why there's so many caves found in limestone terrain. Like if I go up here to the next door states, Tennessee and Kentucky, there's lots of limestone and there's lots and lots of caves. But what we want to look at is the climate over the region of Egypt and its nearest neighbor, Libya, to the west, and in fact, for that matter, the whole Sahara Desert, the whole Sahara Desert region of North Africa. So, numerous studies, and I mean, there's dozens of more than I've read, but I've read plenty enough of those studies to know that the Sahara Desert was not, in fact, has not for long actually been a desert. We don't have to go back too many thousands of years when we get to the point where it isn't a desert. In fact, it's almost lush. And so that's what we're going to talk a little bit about here. I want to introduce some of these studies to you and see what this may imply as far as the question of could there be or could there not be structures under the Giza Plateau and under the pyramid complex. So I'm going to begin by talking about a 2011 report that was published in the Proceedings of the National Academy of Sciences. And in this report, they discussed evidence that the Saharan Desert was not always an obstacle to the dispersal of humans northward, the out of Africa theory that you've probably heard of, that humans moved primarily from the equatorial regions and near the in eastern Africa near the Great Rift area, and then moved northward and eventually colonized all the way up to the Mediterranean. But the problem is that if people didn't have the means to travel across 1,000 miles of desert, the desert would actually act as an obstacle to the migration of human population. Because for one thing, if it's the kind of desert that it is there now, there's not a whole lot to support life. At least the kind that you would expect would be accessible to a roving band of humans. So in this report, I'm going to quote from it, the authors say that there was five authors, and the title of the paper that I'm going to quote from is Ancient Watercourses and Biogeography of the Sahara Explain the peopling of the desert. Okay, so what made possible this migration across what is now the vast wasteland of the Sahara Desert was that, quote, during the Holocene humid period. Now, the Holocene, remember, the Holocene is the geological epoch that we're in right now. It goes back, it's dated. The date that is now given in the literature is 11,500 to 11,600 years ago, which is a very interesting date because that is a date of one of the great meltwater pulses and sea level rise events that occurred in the transition from the preceding epoch, the Pleistocene, into the modern epoch, the Holocene. And so it is within the Holocene that essentially the modern story of civilization and the rise of organized societies has taken place. Because if we go back 10,000 years, we see the beginning of organized agriculture. We see a shift from nomadic to sedentary lifestyles. We see the dispersion of languages. Not long after that, we see some of the first urban complexes in the Middle East. Well, it's during this period of time that these authors are referring to that was also the Egyptian humid period. So this is what they say. During the Holocene humid period, the region contained a series of linked lakes, rivers, and inland deltas comprising a large interlinked waterway, channeling water and animals into and across the Sahara, thus facilitating these dispersals. The system was last active in the early Holocene when many species appear to have occupied the entire Sahara Desert, which wasn't a desert. They then go on to say, the Sahara was formerly covered by a dense paleo river network with many channels containing very large alluvial fans. Now, what's an alluvial fan? Well, an alluvial fan, if the water is flowing through a constriction and eroding material, and entraining that material into its water flow, and it's flowing in a confined channel, when it opens, say, into a wider channel or a basin, what happens is the water spreads out, it slows down. As it slows down, it loses its competency to carry sediment, and it begins to dump that sediment. And it builds what are called alluvial fans. Alluvial, meaning deposited by water. That's all that means. And it looks like a fan. It's splayed out. Like oftentimes you'll have a mountain, a narrow mountain canyon opens out onto a wider valley. And there you're going to see these fan-like structures spread out. Well, there's many fan structures that are essentially fossil features. They're not really being created on the same scale now in many mountain environments that they were at another time. The same goes for Egypt. So he says the Sahara was formerly covered by a dense paleo river network with many channels containing very large alluvial fans where rivers divide into multiple branches in an inland area. The Green Sahara also contained numerous closed basins that supported some very large lakes. When these lakes were full, they would have overflowed, thereby linking adjacent catchments. Many fans and lake spillways are located in strategic positions that link waterways across the desert. So what's being described here is so drastically and dramatically different than what's there now. And the supposition here is that migrating humans found this to be a completely hospitable terrain rather than inhospitable, and probably, in fact, occupied this whole region of North Africa, which is very interesting because now you have to begin to ask the question, well, how did it change so quickly? Which it did, because we're looking at a period that might have lasted from 6,000 to maybe 9 or 10,000 years ago, the humid period. Now, the evidence also shows, as we'll go on to look at here, that that humid period was only like the most recent phase in an alternating environmental context between desert and temperate region. And there have been multiple shifts back and forth, is what the evidence is now suggesting. Here we have scientific evidence that Earth was blasted around 12,900 years ago by a multi-impact event. I think we're kind of in this phase right now where it's essentially trying to reverse engineer what these peoples of long ago were up to with all of this stuff.
Yeah.
And I ultimately think it's technological.
It's fascinating stuff, isn't it?
Isn't it, though?
Oh, yeah.
Okay, so I go on Rogan with Graham Hancock. And Graham invited me to go on with him. We'd been on there before multiple times. And I had, when Graham was researching his books and stuff, in at least one case, I'd been out in the field with him at least a couple of times, guiding him and showing him evidence in the landscape for these tremendous catastrophic events, which he then documents, like in the book Magicians of the Gods. I think there's 2 chapters in there devoted to our travels together and the things that I was showing him. Well, anyways, before we go in, he says, because, Graham has been attacked left and right by the mainstream guys, the archaeological establishment and all. He says, let's not get into talking about ancient technology. Okay, if you don't want to, I'm fine. I'm happy to talk about mass extinctions or giant floods or asteroid impacts or whatever. I'm sure, yeah. Well, then the issue came up of the ancient builders and how they moved 200-ton stones. So Joe is like, well, did they have some technological means? And if you go back and watch that November show from, they kind of both look at me. Well, wait a minute now. I'm thinking, I just said I was not going to talk about that, right? So I was evasive. But Joe, you can you'll see, I'm trying to not talk about, and Joe, no, whoa, come on, what do you. So I mentioned that, well, I'd been talking to this inventor for about 7 years, and he's been developing these technologies using plasma, and it's frequency-based, right? And at this point, I already knew that the thunderstorm generator, and I'll show you pictures of one now that's been retrofitted on a 300-kilowatt generator on a substation outside of London. And they're testing the damn thing. And it works. It does what it's predicted to do, right? Now, I knew at the time, this is February, a year ago last month, I knew that there was a whole series of testing coming up the next summer, which was last summer. And I was present at some of these tests and saw for myself what was happening, and was able to, there with an admiral, a retired admiral from the Indian Navy, flew all the way over from India to be there present at this testing that was at a major industrial laboratory at one of the research labs out in Raleigh, North Carolina. That's all at this point that I can say about it, but until the final test results are published. But I was there, saw it working, saw 2 generators, a control generator and one with the technology. I watched as the engineers and the scientists there calibrated them both. And then I was the one who went up and started both generators. They're both in 2 separate rooms. Started the technology on one of the generators. And so we've got readouts. We've got gas analyzers there, probes going up into the exhausts of the generators. We've got a couple of guys there with mass spectrometers hooked up. So we've got multiple ways of determining what's coming out of the exhaust pipes of these 2 generators, right?
Yep.
I go up there and I flip the switch on the one that has the thunderstorm. I'll call it the thunderstorm, the plasma generating retrofit to it. And we watch. So we got a first read. I can show you, actually. I've got a printout of the readouts right here on my computer.
Really?
Yeah, I do. And you can see you've got, I think it's called a Kane 5 something, because it measures 5 gases. Carbon dioxide, carbon monoxide, nitrogen oxide, other hydrocarbons, probably like methane and whatever else, and oxygen. Okay, so flip the technology on. You can sit there, I can watch the mass spectrometer, I can watch the gas analyzer. You're looking at like 10% or parts per million. Let's see. Carbon dioxide, carbon monoxide, and oxygen were in percentages. Methane and nitrogen oxide were in parts per million. So basically, oxygen is like at a 4 or 5% coming out of the exhaust, which is about typical for a generator like that. You got, I think, like 10, 11 was it 12% of CO2, CO, etc. So as you're watching it, here's what happens. The carbon dioxide, carbon monoxide, methane, hydrocarbons, and nitrogen oxides start going down. Oxygen starts coming up.
Interesting.
CO2 zeroes out. Carbon monoxide zeroes out. The nitrogen oxides go down to just a few parts per million, as does the other hydrocarbons. Oxygen tops out at over 20, I don't remember exactly, between 20 and 21%, which is optimum percentage of oxygen for pure unpolluted air. So what is now coming out of the generator, the generator with the technology, is pure unpolluted air.
No kidding.
No kidding. No
Whoa.
kidding. Yeah. On top of that, what it's doing, it's capturing everything that's coming out, and it's feeding it back into the thunderstorm generator. So at the initial, in order to get the plasma separation to occur, I think you have to get it up to like 700 and some degrees. But once you do that, it's almost, not quite, but almost self-perpetuating. And you just have to replenish the water. Like, I forget, however few hundred hours that it runs, you have to replenish the water. And that's it.
Man, and you've seen this.
Oh yeah, I've seen it. And I've known, multiple people now that have seen it. The Admiral, he took it back to India. India is seriously looking at it and as a retrofit for their Navy.
Man.
The industrial, and I can show you this on the computer too. I've got photographs of like the big industrial scale application on the 300 kilowatt Perkins generator on the substation in London. I mean, they're testing it, and they may start retrofitting all of their because it doubles to triples the efficiency of these engines.
Wow.
Yeah.
Wow. And you think that they had this back in ancient times?
Some iteration of it, I suspect. And here, now, it just gets more bizarre as we go on.